Welcome to this video where we are going to talk about one interesting and important data processing framework which is extremely fast and performs in-memory computation. It is Apache Spark. Apache Spark is that cluster computing framework which takes the advantage of distributed processing. That is, we process data across different machines in memory. By in-memory, we mean most of the processing and intermediate output resides in the RAM of the machines. This, however, increases the RAM requirement but performs a processing which is extremely fast than the traditional systems or even compared to MapReduce. Apache Spark development can be made in diverse languages, which includes Java, Scala, and Python. It also offers interactive shell in Python and Scala. So let's get started about Apache Spark. Let us compare the MapReduce and Apache Spark first. If you are coming from MapReduce context, both are distributed computation framework. But Spark is a unified framework in which you can perform stream processing, you can perform SQL operations or graph operations or machine learning or a traditional ETL in the same program. In MapReduce, there is a map phase, there is a reduce phase, there is a shuffle phase in between, but in Spark, there is no tight coupling between a map or a reduce phase. There is a task which can be map or shuffle or reduce or any other else. This brings Spark much efficiency in its execution because after a reduce, you can call another reduce without any map in between. More thrust is on keeping data in memory as much as possible. In MapReduce programs, we have got job objects, whereas in a Spark, we have got a Spark context object, which handles the execution of the Spark job. We will talk about a Spark context once we go to the architecture of a Spark as well. Ultimately, it's faster in execution and it's very quick in development. The first thing is how you can install Apache Spark on your machine. It's very simple. Just go to this particular link on the screen and get the binary executable of the Spark. In my case, I'm using Acadgild sandbox and I have downloaded the Apache Spark. Apache Spark is present at this particular location, home Acadgild Spark. I have unzipped the tar as well. Once you unzip the tar, you will find there are lots of directories inside it. For our use case, we will focus on the bin directory, which contains lots more executable files. Once you type bin/PySpark, it will give you the Python interactive shell for this Spark. Meanwhile, if we talk about the most active open source project in big data, it is undoubtedly the Spark, which is having a lot more attraction. The very first thing we have to talk about Apache Spark is the resilient distributed data sets, which are also called as RDDs. Suppose you have got some data present in the HDFS. Assume like this is the actual data, which is extremely large in volume. With Spark, different portions of the data can be processed in parallel across different machines. These are basically called the partitions. It may be possible that different partitions are on different machines. Ultimately, this is called an RDD with partition 3 in our example. Every partition can be on different machines, so it is called distributed data set. If one of the partition goes down because of the power or network failure of a machine, only that specific partition is recreated on a different machine. and that happens completely automatic without any user intervention. That is the reason why they are called resilient, because they are fault tolerant. RDDs can be created from any list in Python or from existing RDDs. These RDDs are immutable, so whenever you have to make any change, you will have to create a new RDD. Or you can create RDD from any other file present in any of these storage systems like SDFS or S3. Having taken this small idea about the RDDs, it makes sense to go forward. When we talk about any operation on the RDD, they are of two categories. One is transformation and one is action. Transformation is any operation which creates a new RDD, whereas action is any operation which gives some result out of your processing. Let us take an example. We are going to talk about a data set. This data set is of Soccer World Cup data set. It is a tab separated file where the first field is the category, the group of the country, second is the country name, third is the rank, then we have got the player number, player position, age of the player, number of selections, and the organization for which, or the club for which the player has played, name of player, and finally whether the player is a captain or not. If it is 0, it means he's not a captain. If it is 1, it means he's a captain. We are going to process some operations on this particular data set. Let us get us started. The very first thing is, once you open the Spark shell, you type sc, you will find there is a Spark context object available for us with the reference variable sc. Once you call sc.text file and give the location of the data set, you are able to load an RDD. Let us give the name base RDD. Once your base RDD is created, if you type base RDD, you will find that it is a map partitions RDD, which is the type of RDD present in Apache Spark. If you want to see how many entries are there, you can use .count and it will perform the processing and give you how many entries are there. There are 736 entries in this particular RDD. If you want to take some of the elements of the RDD, you can use base RDD.take and give the number, say 2. I want to take 2 elements. You will be able to see this is the first element of the RDD. Obviously, it's separated by tab, which is represented by \t. And this is your second element of the RDD, again delimited by a tab. Obviously, this is not the way which you would like to see the data. So what you can do is you can simply use a Pythonic loop to print the elements of the loop, and you can type for I in base RDD dot take 2, and for every I you want to print I. This will give you a lot more readable output of the data set. Till now, let us go back to the transformation and action. The very first line which we executed, the xc.text file, this is a kind of transformation because it gives you one RDD in the output. Whereas the RDD has got methods like count and take. These are the operations because they do not return an RDD, rather they return some values in the form of an integer or in the form of a list or maybe different output. So this is about the RDDs, and one important point to know here is RDDs are lazily evaluated. The lazy evaluation. What is this lazy evaluation all about? Let us go back to the command and give a wrong name while creating the RDD, like underscore incorrect. This is a file which does not exist. If you type this, you won't get any error, any warning, nothing. You won't receive any output on the screen. But the moment you call take 2, you will receive an error that the input path does not exist. Now, this is the lazy evaluation. The first time you create any RDD, that is whenever you call any transformation, no activity is performed. Activities are executed, all the operations are performed whenever you require the result or whenever you call the action. Action, the examples of action can be count or take. There are many other actions available, but the point is transformations are not executed unless you call any action. Whenever you prepare any transformation, only the directed acyclic graph is maintained in the Spark, which is later executed whenever first time you call the action. This is a very important principle in a Spark because this gives the Spark a luxury, a comfort to perform any optimization before execution. Let's go ahead and talk a few more points about the RDDs. You can create RDDs for testing purpose or for small development from the list. You can create a list of your own choice, put some entries, and you can create an RDD by using sc.parallelize. You can also control the number of partitions. Always remember, the more the partition you have, more will be the parallelism because every partition is executed in parallel across different machines. So while creating the RDD, you can specify the number of partitions as well. Or if you have not specified it, you can perform repartition after a certain amount of time whenever you feel like. So we have talked about how to create an RDD from a file, what is the lazy evaluation, how to control the partitions of a file. This is how the architecture of Apache Spark looks like. First of all, we have got a Spark context object which is present in our program, and this Spark context object is responsible to control the life cycle of the Spark application execution. The Spark tasks are performed in parallel across multiple machines called as worker machines. For local development, you can have a local thread running on the same machine where your Spark context is. In between, there is a cluster manager which performs the resource allocation. How many resources are required, how many machines may be required for the purpose. This is maintained by the cluster manager. Cluster manager can be Yarn or it can be the standalone Spark cluster manager. You can also use Apache Mesos as a cluster manager. It is the worker thread which performs the tasks in parallel across different machines, and they use certain file system, certain storage, maybe S3 or SDFS or any other storage for the retrieval or for producing data as an output. So let's talk more about the Spark program which we have just seen. We have created a base RDD. If you want to see how many partitions are there, you can use the method getNumPartitions. In this example, we are having only one partition, and that is also running in the local mode. Let us talk about the filter operations. Whenever you call the method filter, every element of the RDD is evaluated against the method which you pass as an argument. So basically, this is a method, or you can call it as a function. This function, it is a lambda function, a function without any name. It receives an input called as x. It performs x.split on the basis of tab and takes the second element. If the second element is in Australia or Brazil, any one of these two, that is considered to be the output, else it is not considered to be in the output. So filter operation is like a where clause in the SQL, where every element of the RDD is compared against certain conditions. If that condition matches, we take that entry, else we discard that entry. So from here, with the help of filter over the base RDD, we are producing one more RDD called as filter RDD. Remember, RDDs are immutable, so whenever you want to make any change in the existing RDD, you have to create a new RDD. So this is the filter RDD which we are going to create. If you can take the count on the filter RDD, you will understand the difference. Filter RDD has got only 46 records, whereas the base RDD has got 736 records. So obviously filter RDD is a subset of the base RDD. If you want to see how many partitions are there for the filter RDD, you can call the getNumPartitions method, and it also has got one partition. By default, the number of partitions in an RDD equals the number of partition in its parent RDD. If you want to perform any repartition, you are free to do that by using repartition method. I'll show you. If you want to create repartitioned RDD is equal to filter RDD dot, there is a method called as repartition, and you can specify the number of partitions. I'm taking it as a 4. If you want to see how many entries are there, or basically partitions are there in the repartitioned RDD, you can use getNumPartitions, and it will give you 4. This is what we were looking for. Now, if you want not all the data from an RDD, rather a specific column or a specific field, you can perform map operation. It will take in every element of the RDD one by one, and then it will perform the logic specified in your function, which you pass as an argument. See the beauty of the program. You are going to pass a function as an argument, which is available in Java 1.8 or Python or Scala. So let's create one RDD called as MapRDD is equal to, let's take a repartitioned RDD and perform map operation. For every input X, I am going to produce X, splitting on the basis of tab first, and then taking out the second element, or let's take out the element at position 8. Okay, let's use a correct name. It's not AMP, it's MAP. Now, if you want to see the few elements from map RDD, if you take 10 elements, you will see basically I have been able to extract only the name from the RDDs. So we had every line as a record containing multiple fields, and we are able to extract a particular field of our choice by using map method over the RDD. Additionally, you want to save the player's name in the file system, you can use save as text file method, which is again an action. So this is the directory location where all your content will be saved. Let's go and check it out. If you want to see the content inside this particular directory, you will see there are 4 part files because that particular RDD had 4 partitions. Output of every partition has been written to this particular file. And if you want to see one of the content from this particular file, so let's do that and check how the content looks like. See, this is one of the files which contains the names of the players. So what we have done, first of all, we created an RDD using Spark context object and the text file present at certain location. We filtered out the RDD by the country name. So if a record belongs to Australia or Brazil country, we have filtered it out, and then we have selected the name of the players and saved it to this particular location in our file system. So I hope you got an idea about what exactly is Spark, how is it better or how is it efficient than MapReduce. We also came across the architecture of the Spark, the RDDs, and some hands-on over the RDDs. I hope this gives you an introduction and quick start with Apache Spark. Please stay tuned to Acadgild videos for more introduction on the Hadoop ecosystem components. Thank you.